The technical interview, in its current form, has existed largely unchanged for well over a decade. A candidate is given an algorithmic problem, often involving data structures rarely encountered in day-to-day engineering work, and asked to produce a working solution under time pressure, frequently on a whiteboard or in a stripped-down coding environment with no access to the tools an engineer would normally use. This format has become the default gate into the profession at a majority of technology companies. It has also, for nearly as long as it has existed, been criticized by the very organizations that rely on it. That contradiction is worth examining directly. The core issue is a mismatch between what the format measures and what the job requires. Solving a constrained algorithmic puzzle from memory under time pressure draws primarily on pattern recognition and rehearsed preparation. The actual work of software engineering, understanding an existing system, scoping a change correctly, anticipating edge cases, verifying behavior, communicating trade-offs, is largely absent from this format. A candidate can perform well on the former while being unprepared for the latter, and the reverse is equally true. Engineering organizations have long suspected this. Several large technology companies have published internal analyses over the years, finding limited correlation between algorithmic interview performance and subsequent on-the-job performance ratings. The suspicion is not new. What has changed is the cost of continuing to rely on it anyway. There is a well-established body of research in personnel psychology addressing exactly this problem, though it is rarely applied rigorously in software hiring. Unstructured interviews, including most technical interviews as currently practiced, are among the weaker predictors of job performance available to employers, with meta-analytic correlations typically in a modest range. Structured work sample testing, by contrast, in which a candidate performs a task closely resembling actual job responsibilities, consistently ranks among the strongest available predictors, outperforming interviews and years of experience heuristics. This is not a new or speculative finding. It has been documented and replicated across decades of industrial organizational psychology research, predating software engineering as a discipline entirely. The gap is not a lack of evidence, it is a lack of adoption. There are practical reasons this gap has persisted. Realistic work sample assessment is expensive to build and expensive to grade. A well-constructed algorithmic problem can be reused indefinitely with an automated test suite and requires no domain-specific infrastructure. A realistic work sample, a partially built application, a production-shaped code base, a task requiring judgment rather than a single correct answer, requires meaningful engineering investment to construct and historically required a human evaluator to grade consistently, which does not scale. For most organizations, the algorithmic interview persisted not because it was believed to be accurate, but because the honest alternative was operationally difficult to deliver at scale. That constraint has changed substantially in the past 2 years. Large language models can now grade a candidate's work against a hidden reference solution and a structured rubric with a level of consistency that would previously have required a trained human evaluator for every submission. Realistic engineering environments, full, containerized, runnable codebases rather than isolated functions, can now be constructed and maintained at a fraction of the cost required even 5 years ago. Academic benchmarking work in this area has independently validated the underlying premise, evaluating engineers against real, verifiable, repository-level tasks, where success is defined by whether hidden tests pass, not by similarity to a reference answer, produces a meaningfully better proxy for engineering capability than isolated function-level problems. The infrastructure objection that justified sticking with the algorithmic interview no longer holds with the same force it once did. This creates a specific opportunity and a specific risk for organizations currently evaluating how to hire technical talent. The opportunity is that structured, realistic work sample assessment, long known to be one of the better predictors available and long avoided for cost reasons, is now operationally viable at scale for the first time. The risk is that many organizations will not update their process accordingly, will continue relying on a format most already privately suspect is a weak predictor, and will do so at a moment when that format has become even less reliable for the reasons outlined in our previous release regarding AI-assisted performance during interviews specifically. We want to be precise about what we are and are not claiming here. We are not asserting that any assessment format, including realistic work sample testing, can achieve certainty about future job performance. No instrument in this research area does. What the evidence supports is a more modest and more defensible claim that realistic, verified, work sample-based assessment is a meaningfully stronger predictor than the algorithmic interview format currently used by the majority of the industry, and that the primary historical obstacle to adopting it, cost and scalability, has substantially eroded. An organization continuing to rely primarily on algorithmic interviews today is not doing so because the evidence favors that choice. It is doing so because the alternative was, until recently, genuinely difficult to build. This is the specific gap our platform is built to close, not by inventing a new theory of assessment, but by making an already well-supported one operationally practical. Realistic, containerized engineering environments, graded consistently against verified reference solutions, reported with appropriate statistical honesty about confidence rather than false precision. We will continue to publish our findings as this research develops, including the results of our own validation work as sufficient data accumulates to report them responsibly.